Welcome to our channel. Today, we discuss one of the most urgent and dramatic transformations unfolding on our planet, the rapid disappearance of Arctic ice and what it could mean for the world in the 2030s. Picture a place defined by endless white horizons, seas frozen through most of the year, and a delicate balance of life that has endured for thousands of generations. This place is the Arctic, and the ice that crowns it is more than just breathtaking scenery. It is one of Earth's most vital regulators, a compass that keeps our global climate on course. Imagine waking up one day to find that vast expanses of sea ice no longer form in winter, that polar bears no longer tread on thick ice floes. That once frozen communities must constantly adapt to a melting reality. This isn't science fiction, it's a rapidly approaching future if current trends continue. In today's video, we're going to explore what happens when the Arctic ice vanishes, the cascade of climate effects, ecological impacts, geopolitical shifts, changes to human life around the world, and why scientists believe the 2030s may be a defining decade. Most people think of climate change as something distant, polar bears on faraway ice caps, melting glaciers in the news, pictures that tug at the heartstrings but seem far removed from daily life. But the Arctic is deeply connected to the rest of the planet. And its ice acts like a giant thermostat. When that thermostat falters, global weather, sea levels, ecosystems, and even our economic systems shift in response. To understand what's at stake, we need to first understand what Arctic ice actually does. The Arctic ice includes sea ice that floats on the ocean, and land-based ice such as glaciers and the Greenland ice sheet. This ice has an incredible ability to reflect sunlight back into space, thanks to its bright, white surface. Scientists call this albedo. When sunlight hits ice, it bounces away, helping to keep the planet cool. When ice melts and exposes darker ocean water, more sunlight is absorbed instead of reflected, warming the water and the atmosphere above it. It's a powerful feedback loop. Less ice leads to more warming, which leads to even less ice. Over the past few decades, satellites have revealed a staggering decline in Arctic sea ice extent. Every summer, the ice melts back, and each year it's been shrinking further. Scientists have observed that not only is the total area of ice decreasing, but the ice that remains is thinner and younger, meaning it's more vulnerable to melting. Unlike old, thick ice that can survive through summer melt seasons, young ice forms quickly in winter and melts quickly in summer. By the 2030s, climate models project that the Arctic could experience its first completely ice-free summer, a momentous and alarming milestone. An ice-free Arctic summer doesn't mean all the ice is gone forever. Some ice will still grow back in winter. But the seasonal disappearance of sea ice would mean open water across large parts of the Arctic Ocean during the warmest months. This might seem like a distant future scenario, but climate data shows we are rapidly approaching it. So what happens when the Arctic becomes nearly ice-free during summer? The immediate consequences are dramatic for the Arctic itself. Species that depend on sea ice for hunting, breeding, and resting will face immense stress. Polar bears, for instance, use the ice as a platform to hunt seals. Without it, they must swim longer distances, expend more energy, and face reduced access to food. Walruses haul out on ice floes to rest between feeds, and without those platforms they crowd onto shorelines, leading to dangerous overcrowding and higher mortality, especially for calves. Arctic foxes, seals, and countless seabirds are also deeply tied to the rhythms of ice and ocean. Indigenous communities that have hunted and lived in harmony with these cycles for generations face cultural and subsistence upheaval. For them, the loss of ice isn't an abstract climate statistic, it's a change to identity, food security, travel routes, and spiritual life, but the repercussions extend far beyond the Arctic Circle. One of the most important global impacts of disappearing ice involves sea level rise. When sea ice melts, it doesn't directly raise sea levels, because floating ice displaces its own volume and water. But land ice melting, particularly from the massive Greenland ice sheet, absolutely does contribute to rising seas. Greenland holds enough ice to raise global sea levels by several meters if it melted entirely. While that total melt would take centuries under current warming scenarios. Even partial acceleration could dramatically alter coastlines within this century.
Rising sea levels threaten coastal cities and communities worldwide. Places like Miami, Mumbai, Bangkok, and Lagos are already grappling with higher tides and more frequent flooding. A meter or two of sea level rise could displace millions of people, create climate refugees, and disrupt global economies. The disappearance of Arctic ice isn't just a polar concern, it's a coastal crisis in the making. Another key consequence of an ice-free Arctic is how it alters weather patterns far from the pole. The Arctic jet stream, a ribbon of fast-moving air that circles the northern hemisphere, is driven in part by the temperature difference between the cold Arctic and warmer mid-latitudes. As the Arctic warms faster than lower latitudes, a phenomenon known as Arctic amplification, that temperature gradient weakens. When the jet stream weakens and becomes wavier, it can slow down and meander. These changes have been linked to persistent weather patterns such as prolonged heat waves, cold spells, droughts, and intense storms. For example, a wavier jet stream might allow frigid Arctic air to plunge southward into places unaccustomed to severe cold, just as it might allow hot air to linger over a region, intensifying heat waves. These shifts not only disrupt agriculture and energy systems but also increase the risk of wildfires, crop failures, and water scarcity. Ocean circulation patterns are affected as well. The Arctic plays a role in driving thermohaline circulation, the global conveyor belt of ocean currents that distributes heat around the planet. Fresh water from melting ice dilutes the salty ocean surface waters, potentially slowing major currents like the Atlantic meridional overturning circulation. If this system slows significantly, certain regions might experience cooler temperatures even as the planet overall warms, a complex and somewhat counterintuitive result of climate disruption. While we focus on the physical impacts, it's crucial not to overlook the economic and geopolitical shifts tied to a melting Arctic. As ice retreats, previously inaccessible sea routes open up. The Northwest Passage, once blocked by thick ice, could become a viable shipping lane for part of the year. Shorter transit routes between Asia, Europe, and North America could reduce fuel costs and travel time for global shipping, presenting economic incentives for nations and companies. At the same time, access to Arctic natural resources, oil, gas, minerals, becomes easier. This poses a paradox. Exploiting these resources could accelerate the very warming that's melting the ice, while the promise of economic gain fuels geopolitical competition. Nations bordering the Arctic, including the United States, Russia, Canada, Norway, and Denmark, via Greenland, are increasingly vying for strategic advantage, raising questions about governance, environmental protection, and indigenous rights. The Arctic Council, a cooperative intergovernmental forum, has thus far helped maintain relative stability and dialogue, but the pressures of climate change and resource interest create tension between economic ambition and environmental stewardship. As global powers look northward, the Arctic becomes not just a thermometer of climate change but a stage for strategic rivalry. Turning back to the environment itself, the loss of Arctic ice has another consequence that isn't immediately obvious: the release of trapped greenhouse gases. The Arctic is home to vast stores of carbon in its frozen soils and permafrost. When permafrost thaws, organic material decomposes and releases carbon dioxide and methane, methane being a particularly potent greenhouse gas. This creates yet another feedback loop: warming causes thawing, thawing releases greenhouse gases, and more greenhouse gases cause further warming. Scientists worry that large-scale permafrost melt could significantly accelerate global temperature rise beyond current model projections. There's also the issue of darkening landscapes. As ice and snow cover shrink, darker land and ocean surfaces are exposed. These surfaces absorb more heat, amplifying warming. This effect isn't limited to the Arctic, it ripples through ecosystems and climate systems globally. Let's pause for a moment and acknowledge the human dimension of all this. While scientists, policymakers, and media talk about ice extent, feedback loops, and climate models, there are real people already feeling these changes. Indigenous peoples in northern communities are facing challenges to traditional ways of life. In places like Alaska and northern Canada, towns are observing shoreline erosion as sea ice that once buffered winter storms no longer forms. Homes and infrastructure are at risk. Hunters who once relied on stable ice to travel and hunt now contend with unpredictable conditions that endanger lives. In some areas, communities have been forced to relocate entirely, a heartbreaking process laden with cultural loss. economic strain, and emotional toll. The local knowledge of weather patterns, ice behavior, and seasonal rhythms, accumulated over generations, becomes less reliable as the climate changes. Adapting isn't simply a matter of building new homes, it involves reshaping entire identities deeply rooted in the Arctic landscape. Despite the stark nature of these changes, it's important to recognize that the future isn't predetermined. The timing and severity of Arctic ice loss depend largely on actions taken now. Climate scientists have been clear: reducing greenhouse gas emissions, transitioning to clean energy, preserving natural carbon sinks like forests and wetlands, and improving energy efficiency can slow the pace of warming. If global temperature rise is limited, the worst-case scenarios of rapid ice loss may be averted or mitigated, but delaying action has consequences of its own. Greenhouse gases already in the atmosphere set decades of warming in motion. The choices we make in this decade, not just in policy circles but in individual, community, business, and national decisions, influence the trajectory of our climate system for generations. There's reason for urgency, but also reason for hope. Technological advancements in renewable energy, international agreements geared toward emissions reduction, and increasing public awareness signal that global momentum for climate action is growing. Young people around the world are demanding climate responsibility from leaders and businesses. Cities are committing to zero-emission transportation. Corporations are investing in sustainable practices. And scientists continue refining our understanding of climate processes, helping policymakers craft more effective strategies. At the same time, adapting to changes already underway is essential. Coastal defenses, resilient infrastructure, disaster preparedness, and community planning must account for rising seas, shifting weather patterns, and ecological disruption. Integrating traditional knowledge with modern science offers powerful insights into adaptation strategies for communities on the front lines. There's also a critical role for public engagement. Understanding the connections between Arctic ice and everyday life, from food prices affected by weather disruptions to the increasing severity of storms, helps demystify the science and empowers people to support meaningful action. So let's return for a moment to what an ice-free Arctic summer might look like for someone halfway around the world. Maybe you live in a city near the coast and have noticed that storms seem more intense each year. Maybe farmers in your region face unpredictable rainfall, affecting crop yields and food prices. Maybe you've endured a summer heatwave that felt unbearable. These experiences are all part of the same planetary system that is altered by the loss of Arctic ice. Though the Arctic might feel distant geographically, it is deeply connected to weather, climate, and human well-being everywhere. Of course, not all impacts will play out uniformly. Some regions may initially see certain benefits, longer shipping seasons in northern waters, for example, but these are accompanied by broader costs that outweigh isolated advantages. Short-term economic opportunities don't negate the systemic risks of planetary warming. It's also worth considering how the narrative around the Arctic fits into our collective imagination of climate change. For many decades, the image of melting ice and stranded polar bears was symbolic, a visual shorthand for global warming. But what's happening now goes beyond symbolism. It is measurable, consequential, and accelerating. The story of the Arctic is no longer just a cautionary tale from a remote frontier, it's a central chapter in the story of our shared climate future. In reflecting on this, it's useful to think of Earth as a complex, interconnected system. Changes in one part inevitably ripple through the rest. Climate isn't a static backdrop, it's a dynamic interplay of land, ocean, ice, atmosphere, and life. When one component, like Arctic ice, changes dramatically, the entire system adjusts, often in ways that surprise and challenge us. That's why the possibility of a mostly ice-free Arctic in summer by the 2030s is so significant. It's a threshold moment, not just for polar ecosystems, but for global climate stability. Threshold moments aren't gentle. They are tipping points that signal a shift in how systems function, but tipping points also remind us that systems can be influenced. The difference between 1.5 degrees Celsius and 2 degrees Celsius of warming, for example, may seem small numerically, but it has huge implications for sea ice, coral reefs, extreme weather, and human societies. Every fraction of a degree matters because it changes how feedback loops interact, how ice responds, how oceans absorb heat, and how ecosystems adapt. So as we imagine the Arctic of the 2030s, perhaps with open water where there was once ice, it's important to grasp both the urgency and the agency we possess. The timeline for ice loss isn't fixed, it responds to human choices. Reducing emissions this decade could delay or soften the loss of Arctic ice, giving ecosystems and communities more time to adapt, and reducing the severity of knock-on effects around the world. And beyond mitigation and adaptation, there's a deeper, more philosophical question embedded in the Arctic's transformation. What kind of relationship do we want with our planet? Do we see nature as a resource to exploit, or as a system we are part of and depend on? The fate of Arctic ice asks us to expand our sense of responsibility, not just to distant places and species, but to the integrated network of life and climate that supports us all. By shining a spotlight on what happens as Arctic ice vanishes, we hope to spark not just concern, but curiosity, empathy, and action. The future we face will be shaped by the policies we enact, the technologies we develop, the norms we uphold, and the choices we make each day, from the energy we use to the voices we raise for climate solutions. As we wrap up, let's revisit the big picture. The Arctic ice that has persisted for millennia is retreating at a remarkable pace, with scientists projecting a potentially ice-free Arctic summer in the 2030s. This matters far beyond the Arctic Circle. It influences global weather, sea levels, ecosystems, economies, human communities, and geopolitical dynamics. It's a marker of how quickly our climate is changing and a reminder that urgent, thoughtful action matters. We invite you to think about what you've learned here today. Consider sharing this video with someone who might not realize just how critical the Arctic's future is to our own. Leave a comment below with your thoughts. Do you think the world is doing enough to address climate change? What impacts have you noticed in your region? Let's build a meaningful conversation together. If you found this video informative and thought-provoking, please give it a thumbs up, subscribe to our channel for more deep dives into issues shaping our world, and ring the notification bell so you never miss an update. Your engagement helps this channel grow and spreads awareness about topics that matter. Thanks for watching, and we'll see you in the next video.